So this is a catch-up for just going through some static electricity stuff. So we started the lesson by watching this video. If you want to watch it yourself, it's about just show some thunderstorms, and we started to talk about what lightning was caused by. And then the big, oh hang on, it's just going to play, sorry. Okay, so then the big question today is thinking about what is static electricity and why does it make our hair stand on end. So for bronze, you need to identify the charges of particles within an atom. For silver, describe the effect of the transfer of electrons. And then for gold, explain the effect of the transfer of electrons using examples which you can demonstrate in the classroom. So we started talking about these balloons. So when you rub a balloon, you can then generate this static electricity, and we started to talk about what that actually was and what's happening. So the key term we're using here is friction. So when you rub the balloon on a jumper, you generate the force of friction. What that friction does is it transfers some of the electrons from the outer shell of the atom away from the balloon. So when you rub it, the electrons come off the balloon and would perhaps go, if when you rubbed it, they would go on your jumper, say. That would mean your jumper would receive lots of negative electrons and become negative, and your balloon would lose negative electrons and become positive. Because the balloon is now positive, this baby's hair has no charge, okay, then that would mean that they would be attracted to each other. So an example from a classroom is this Van de Graaff generator. What we have here is, so we're looking for some friction. So what it is a rubber belt that's pulled along by two pulleys. And if you search for Van de Graaff generator in YouTube, you can find some videos showing what happens. But underneath here, there's like a comb, and the comb generates friction because it scrapes the rubber. And what happens is the comb will scrape the electrons off the rubber belt, okay, and transfer them to the dome. The dome becomes negative and then the rubber belt is positive. Now, if you don't put anything near the dome, the charge will just sit there building up and building up and building up. And what the charge will want to do is it will want to go to Earth because Earth has no charge. So it will look for the quickest way to get to Earth. So if you then touch the Van de Graaff generator once it's charged, you will get an electric shock because you are connected to Earth. So the electrons will jump from you down through into the Earth. Okay, if you charge it with it, so if you were to put your hand, turn it off, discharge it, and then put your hands on it, and then you charge it with it, what happens is all the negative electrons get deposited on you. Sorry. All the negative electrons get deposited on you and your hair. So what happens there is your negative hairs all repel each other and it will stand up on end. And what you can do is find a video for that to see that happening, okay? So this is the key main point that we're looking for electrostatics. Explain how the person can be charged as they walk across the carpet and then maybe get a shock when they touch something. So as a person walks across a carpet in socks, there is friction. Around the atoms of the socks and the carpet atoms, there are electrons, okay, which have charge. They have a negative charge. The charge builds up until the person touches something connected to Earth. The electrons then travel to Earth and can cause a shock. Okay. And this is what happens in lightning. Okay, so we could change these sentences to be like lightning. So as water particles in cloud rub against each other, there is friction. Okay, the atoms in the clouds lose their electrons and they travel to the bottom of the clouds where they build up and they have a negative charge. Okay, the charge builds up until it's able to jump to the Earth, and this causes a lightning strike. So it's all using the same key terms. So what I want you to do is, with this lesson, there's an exam question. I want you to have a go at the exam question and then use the mark scheme to answer it. But you should see here, you'll be using these words. The very last thing you need to know for this lesson is about electric fields. So if you have a charged particle like this negative electron, around it is a field, and that field is where you would feel the force. So it's not a field like a field with like grass in. In physics, a field is an area where you feel a force. So for example, around the Earth there's a gravitational field, so if you were in that gravitational field you would feel the force of gravity. So around these charged particles you feel a force. So they both have the same shape. So if they're circular, they both have this shape like the spokes of a wheel, positive and negative. You need to draw at least 5 lines if you're asked to draw these. The direction is determined by, if you were to put a positive charge in the field, what direction would it go? So if I was to put a little positive charge here, it would be attracted to the negative electron, so it would move in. If I was to put a positive charge here, it would be repelled by the positive proton and it would be pushed away. Okay, so you need to draw these down. Right, thank you very much. Have a go at the exam question, see how you get on.